All right, we're going to talk about complex numbers today. You may have already seen this in the past, so this might just be a review for you. A complex number is an expression in the form of a plus bi, where a and b are real numbers, like 1, 2, 3, or negative 1, 2, 3, and I squared equals negative 1, so I by itself is an imaginary number. The real part of the complex number is a, the imaginary part is b. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal as well. So here are some examples. 3 plus 4i. The real part here is 3. The imaginary part is 4. 1/2 minus 2/3 I. The real part is 1/2. The imaginary part is negative 2/3, because you got to include that negative as well. This one's 6i. The real part is 0. Okay, so it's like having a 0 plus 6i here. Okay, that makes it real part 0, imaginary part 6. And then similar for the next one, negative 7. The real part is negative 7. It's like having an imaginary part 0 here plus 0i. Okay, so those are also complex numbers with real and imaginary parts. So there are just some notes here for adding, subtracting, multiplying complex numbers. When you add them, you add the real parts together, and then you add the imaginary parts together and get a bigger or smaller real part and a bigger or smaller imaginary part, and you leave it like that. So it's similar with subtracting. You subtract the real parts and then you subtract the imaginary parts and then kind of combine those together. For multiplication, this looks confusing because it says that you combine them so that it looks like AC minus BD plus AD times plus BCI. So that's confusing, but basically it's just FOIL. So if you wanted to multiply this out right here, and then multiply that one out to both terms, you would get this answer here, over here on the right side. So the best way to do that is to do some practice right now. All right, example 2. Express the following in the form of a plus bi. So a, the first one is 3 plus 5 plus 4 minus 2i. So basically you're just adding all of it together, so you can rewrite it without the parentheses. And then you just combine what goes together. Okay, so this becomes 7, and then 5 minus 2 is positive 3i, and that's your answer there. For b, you actually, remember, for any minus and then in parentheses, you're going to multiply that negative through, and that'd be like subtracting from both, which is what it said we're going to do. So we just rewrite this, the first thing the same, and then you change all of the second values. So that negative 2i becomes positive, and then you combine what you know. So this becomes negative 1. You always put the real number first, even if it's negative, and then plus 7i. Okay, and then this multiplication one, you just multiply them together like FOIL. Okay, so I'm going to multiply the 3 times both first, and I'm going to get 12 minus 6i, and then I'm going to multiply that 5i times both, and I'm going to get plus 20i minus 10i squared. And so this is where where we can combine stuff. So I'm going to leave my 12 alone for now. I'm going to combine my two i's, negative 6 and positive 20 is positive 14i. And then this negative 10, and remember, I squared is the same as negative 1. So we can change that I squared to negative 1, and then it becomes a real number that we can add to that 12. So this actually becomes positive 10. And we get 22 plus 14i. Okay, and then I to the 23rd is the, whenever you see a big number like that, we need to use this unit circle thing that I think you've learned from Mrs. Horker. Okay, we're going to put I up here, we're going to put I squared over here, we're going to put I to the 3rd down here, we're going to put I to the 4th over here, okay? I is the square root of negative 1. I squared is negative 1. I to the 3rd is negative 1, negative 1 times I is negative I, and I to the 4th is positive 1, because that's going to be I squared times I squared, which is negative 1 times negative 1, which gives you positive 1, okay? So we need to decide where this I to the 23rd falls on here. Well, we can just count around over and over, but I know that I to the 20, I know that I to the 4th, I to the 8th, I to the 12th, I to the 16th, I to the 20th falls over here, so I know I can get to I to the 20th on this side over here. This would be 21 up here, 22, and 23. So our answer would actually fall right here, I to the 3rd, okay, in that section. So it is going to be I to the 23rd equals negative I. All right, here's some more definition notes. A complex conjugate for A minus BI, its complex conjugate is just A plus BI, because when you multiply those together, you get A squared plus B squared. If you do all the math, you'll see, which is a non-negative real number, and that makes it its conjugate, okay? So our examples here are 3 plus 2I, so the complex conjugate of that is 3 minus 2I. The complex conjugate of 1 minus I is going to be 1 plus I. Okay, and then these two down here are a little bit difficult, but if you think of 4I, it's the same as saying 0 plus 4I, and the complex conjugate of that is 0 minus 4I, so that's going to be negative 4I. Okay, and then this one right here, 5, if you think about this one over here, that's like saying 5 plus 0I. Okay, and the complex conjugate of that is 5 minus 0I, which is still 5. So actually, its complex conjugate is still the same. So make sure you understand those on that deeper level in order to get those correct. Our two examples that are left are express the following in the form of A plus BI. So basically, it just wants us to simplify these. So this is where the complex conjugate comes in handy, because when you multiply by the complex conjugate, you get a positive real number every time. So that is helpful for us because that can help us get rid of the denominator down here, which we don't want because we need to simplify this equation. So we need to multiply by its complex conjugate, which is the plus 2i version. Okay, so the bottom down here ends up looking nicer, so you just got to do the FOIL. So I'm going to leave the top for just a second from now. I'm going to do the bottom first. The bottom is 1 plus 2i minus 2i. And see how that cancels? That's going to cancel for us in a second. Minus 2i squared. And that's going to go away. That's going to go away. And then on the top, we're going to FOIL this out in the same way. Okay, and we're going to get 3 plus 6i, and then plus 5i plus 10i squared. Okay, so then we're going to simplify the top. The top becomes 3 plus 11i plus, and remember, this I squared is negative 1. So actually, this is going to be minus 10 on the top. And then the bottom is 1, and then 2i squared is the same as 4i squared, which is negative 1. And then we have this negative in front. So actually, that becomes positive 4 down there. So we are going to get, on the top, we're going to get negative 7 plus 11i over 5. And then they still want it in a plus BI form, so we actually need to break this down to negative 7/5, that's our A, plus 11/5, that's our BI, like that. Okay, that's our answer there. And then, because you want to break it down into that, because it's asking for two different terms. Okay, and then B over here, we're going to do the same thing. We're going to multiply by its complex conjugate. Remember, we did this one above. We want the complex conjugate of 4i, which is negative 4i. Okay, so then the top, we just multiply both of these things times negative 4i, and we get negative 28i minus 12i squared. And then on the bottom, we get a negative times a positive 4, which is negative 16, and then our i's square. And remember, that becomes a positive, non-negative real number. So the bottom is going to simplify. Well, let's simplify the top first. The top is, we need to put our real number first. So this is actually going to be our real number because it's going to be negative 12 times negative 1. So that's going to be positive 12. And then that negative 28i comes over here. And then negative 16 times this positive 1, this negative 1, is going to make it positive 16 on the bottom. And then we need to split that into two terms. So we're going to get 12 over 16 minus 28 over 16i. And then we need to simplify that. That becomes 3/4 minus 7/4 I. And that can stay like that.